Good morning, students. I am SHARMA, teacher of chemistry from Rishikul Vidyapit, coming with a new lecture of solution unit, or we are discussing here sixth lecture today. In fourth lecture, I discussed colligative properties. Regarding that, I discussed only one colligative property, that was relative lowering of vapor pressure. Today, I will take second colligative properties, that is elevation in boiling point, and this is very important term or very important colligative properties, elevation in boiling point. Before to understand this colligative properties, you have to understand what is boiling point. स्टूडेंट्स देखिए, आप घर में देखते हैं, कहते हैं बॉइलिंग का मतलब क्या है। आपकी जैसे मम्मी कहती है, देखो बॉइलिंग वाटर को, दूध को बॉइल करते हैं, वाटर को बॉइल करते हैं। आप देखते हैं कब होती है बॉइलिंग, जब बबलिंग स्टार्ट हो जाती है, तो उसको आप यूं कह देते हैं अब हमारा वाटर क्या हो गया, बॉइल हो गया, या मिल्क क्या हो गया, बॉइल हो गया। बट टेक्निकल डेफिनेशन ऑफ बॉइलिंग पॉइंट इज लाइक दैट. First you write the definition of boiling point. Boiling point means boiling point of a liquid. Boiling point of a liquid is the temperature at which vapor pressure of liquid equal to atmospheric pressure. That is called boiling point. For better understanding, take one pure liquid, or you can say take water here, H2O. That is pure liquid. Suppose at room temperature, its vapor pressure is considered to be 300 millimeter of mercury. This is vapor pressure of pure water, suppose 300 mm. Now we are to boil it. When boiling takes place, now I am putting here atmospheric pressure, and one atmospheric pressure, that is equal to 760 mm, or also you can write 762. Now at room temperature, water can't boil. For boiling it, this temperature or this vapor pressure should reach to 760. How is it possible? By increasing temperature. Now if we increase the temperature slowly, at one time this vapor pressure of water becomes equal to this atmospheric pressure. At that time boiling start. Now take another example. Here I am taking solution, or you can say sugar solution. I am taking here sugar solution at room temperature. This is also at room temperature. Or you can say we have added sugar into water, and sugar is non-volatile. And from an earlier concept, when we add non-volatile solute into pure solvent, then vapor pressure goes on decrease. Right now at room temperature, this vapor pressure is 300 millimeter. Right now this will goes on decrease, and this will be, suppose 200 millimeter of mercury. Now we have to boil it. For boiling, it should reach to 760 mm. That is atmospheric pressure. That is atmospheric pressure. What happens? We are to heat it, or we are to increase the temperature. Now here 300 to 760. What is the difference here? 360 vapor pressure difference. And what about here? I think that is 460. Here difference is more. That is why we give more temperature to boil it. From here we can say vapor pressure of solution is lower than the pure solvent, but boiling point is more than that of boiling point is more for solution as compared to solvent. Or simply we can say here one result comes here, or you can say boiling point is inverse with vapor pressure. Students, boiling point is inverse with vapor pressure. Also you take one more example. Now we know at mountains boiling is easier, or you can say boiling point is lower. Boiling point is lower. What is the reason behind it? At suppose you take example here, you take this water H2, and suppose this is we consider 400 mm, and normally 1 atmosphere pressure, that is 760. Now from here to here we are to, what is the difference? That is 360. Now at mountains this atmospheric pressure is lower. Suppose that is 600 mm and this is 400. What is the difference here? That is 260. Here, to equalize this vapor pressure with this vapor pressure, less temperature is required. Less temperature is required. That is why boiling is fast at mountains. Or you can say here atmospheric pressure is more, boiling point is also more. Here atmospheric pressure is low, that is why boiling point is also low. Or simply one relation can be arrived here. Boiling point also depend upon atmospheric pressure. I just revise the things. Boiling point is that temperature at which vapor pressure of liquid equals to atmospheric pressure. And you know, in addition of non-volatile solute, now this is solution, this is liquid, or that is solvent, and if we add non-volatile solute into this solvent, then what will be there? Solution will be formed. Doing like this, vapor pressure decreases, but boiling point goes on increase. And also from earlier concept, we know vapor pressure is inverse with the force of attraction, we know. And vapor pressure and boiling point also inverse. From here also we can say boiling point that depend upon force of attraction. And you know, I come this term here. Boiling point, you know, that depend upon what? Force of attraction. And in force of attraction, you have to consider what? H bonding first. Then you consider van der Waals force. And you know, hydrogen bonding where present? When hydrogen is that attached with the form is fluorine, oxygen and nitrogen. And in van der Waals force of protection, that depend upon what? Size. That depend upon what? Molecular mass. Molecular mass. First, regarding force of protection, first you have to see hydrogen bonding. If hydrogen bonding is present, then you consider van der Waals force of protection. For more clarity in concept, we take some questions regarding boiling point. Take questions. Question first. और ये कैसे जनरल क्वेश्चन बना लेते हैं. क्वेश्चन, you have to tell which has higher boiling point. Which has higher boiling point. In first question, take this. You take toluene and phenol. In second question, you take ethanol and acetone. In third question, you take this. These three questions we have to solve. Now here, which has higher boiling point? First we see hydrogen bonding. You know, oxygen attached with hydrogen here. Here hydrogen bonding. Here van der Waals. And you know hydrogen bonding is stronger. That is why more force of attraction here. And force of attraction that depend upon what? Boiling point. So this show more boiling point. Now come to here. Here you see. Same type question. Here there is hydrogen bonding. Here van der Waals force of attraction. And hydrogen bonding is strong. Here this ethanol is more boiling point than this. Now these three cases. First case, second case and third case. You know students, what are the name of this compound? This is N-pentane. This one is isopentane and this one is neopentane. Now you see, first is any hydrogen bonding? No hydrogen bonding. Then you consider van der Waals force of protection, and van der Waals force of protection depend upon size and molar mass. And molar mass is same for all three because they have same molecular formula. Now see the size or surface area. This show more surface area because it is a straight chain. Here this has less surface area in comparison of this because here one branching. Here there is two branching. On the basis of this, we say first has more force of attraction. That is why it has more boiling point. We can say first is higher boiling point than second, which in turn then third. Now we understand elevation in boiling point. And we understand it by graphical way. Graphical way. Now take this. This side we take vapor pressure. This side we take temperature in Kelvin. temperature in Kelvin. And here this is atmospheric pressure, and this 1 atmospheric is equal to, that is 760 millimeter or 760 tool also you can write. This is atmospheric pressure. Now you take solvent, pure solvent. You may take water even. Now what happens? When we increase the temperature, what happens? Vapor pressure goes on increase like this. And more you increase the temperature, more will be the vapor pressure. At one time, this vapor pressure touches the atmospheric pressure. On that boiling start, and this is called boiling point. This is the boiling point, and this curve for solvent. And from this curve you can see, with increasing temperature, vapor pressure of solvent goes on increase. At one time, at one temperature, at a particular temperature, this vapor pressure becomes equal to the atmospheric pressure. It means here boiling start, or this is the boiling point, or you can say it is represented T naught B. T naught B means that is boiling point of solvent. And already we have discussed. Now start from solution. Now we know solution has lesser vapor pressure than the solvent, because due to non-volatile solute. Like this, we are here, vapor pressure of solution is lower than the solvent. That is why we have to raise more temperature to equalize the atmospheric pressure. So curve will be like this. And here, this is the boiling point of solution. This is boiling point of solution. Students, this is boiling point of solution. And this difference, which have more boiling point, TB is more than T naught B. Why is it? Due to addition of non-volatile solute. अच्छा बच्चों, एक पॉइंट को ध्यान रखना, बॉइलिंग पॉइंट, जैसे हम सॉल्यूशन की बात करते हैं तो उस सॉल्यूशन में भी जो बॉइलिंग पॉइंट है, दैट इज डिस्कस ओनली फॉर सॉल्वेंट, बिकॉज इट इज फॉर लिक्विड ओनली, बट solute that is non-volatile and that is solid. Here boiling point of pure solvent, boiling point of solution is boiling point of, or you can say here, if you consider here sugar solution, this is boiling point of sugar solution. It means boiling point of water in sugar solution, and here also boiling point of water, pure water. That is, this term should be clear. And this difference TB minus T naught B, that is delta TB. And delta TB, what is it? It is elevation in boiling point. It is elevation in boiling point, and it is equal to final TB minus T naught B. Elevate means that will be increase. Now if you understand like this, if you take water and you add into sugar, by addition of sugar, what happens? Boiling point goes on increase, raise means elevate, and this is delta TB. How you can calculate TB minus T naught B. TB is the boiling point of solution and T naught B boiling point of solvent. And why this elevation take place? By experimental facts, it is found that it is due to the molar concentration of solute into solution, m, small m. This small m, that is molality. And you know what is molality? Number of moles of solute present in 1 kg of solvent. Definition of this is number of moles of solute present in 1 kg of solvent. Keep in mind, 1 kg of solvent, not a solution. You have already studied in 11th class. Now delta TB, in place of this process we put here KB, and this is small. What is KB? KB is boiling point molar elevation constant. Molar elevation constant. Also, another name of it is ebullioscopic constant. Ebullioscopic constant. And how you can explain it? How can you define it? If we consider molarity is 1, or you can say if we take 1 molar solution, then delta TB equal to KB. That is the definition. What is definition of this KB? And that is the mainly asked in board exams many times. What is definition of it? It is elevation in boiling point. It is elevation in boiling point when molarity is 1. And what is the unit of this? From here we can write delta KB can be written as delta TB upon M. SI unit of delta TB. This is temperature. Simply you take Kelvins. And what is the unit of molarity? Mole per kg. And also we can write KB is equal to, that is Kelvin, this will be kg per mole. This is the unit of KB. Students, you understand like this. Delta TB, what is this? This is TB minus T naught B. If here these units are given in centigrade, if suppose here 5, here 2, then we have to add 273 here to form Kelvin, also here 273. So in case of change delta, you need not to add 270 because difference will be same one. Also we can write here in place of Kelvin, we can write centigrade also, centigrade kg per mole. No need to add 273 here in case of delta T. Keep in mind, that will be generally confusing in numericals. So keep in mind, delta T. We know delta TB is equal to what? KB into M. M is molarity. Explain it. Delta TB is equal to KB and molarity, number of moles of solute. NP means number of moles of solute present in 1 kg of solvent. kg of solvent mass के लिए क्या था W and solvent के लिए क्या है A. That is K moles. And if this given in grams, then we can convert it into kg divided by 1000. That is why it comes here 1000. And also we can write delta TB is equal to what? KB into NB. You can write given mass upon molar mass. So we can write here WB upon MB. Here WA, and this is 1000. This is the formula which is generally used in numerical problems, and numericals comes from here. Now we have brought one relation between elevation in boiling point and molar mass of solute, and this one is this KB into में WB upon में MB here WA into में 1000. This formula you will use in numericals. अच्छा बच्चों, एक मैं आपको बात क्लियर कर देता हूं जहां कंफ्यूजन होता है. अगर आपको कभी डेल्टा टीबी सेंटीग्रेड में दे रखा है, सपोज 20 सेंटीग्रेड, you are not to add 273. Reason behind it, because it is the difference of TB minus T naught B. Now if we add here, so here we are to add 273, also here we are to add 270. Difference will be same. That is why no need to add 270. And simply you write it is 20 Kelvin. If you want to change the unit, you can directly change. Now, suppose TB, this is boiling point of solution, that given 20 centigrade. Now it is necessary to add 273 because it is not a change. So this can be converted into Kelvin like this, 273. This will be 293 Kelvin, keep in mind. And also in case of KB, because it is equal to delta TB when molarity is 1. Molarity is 1. Now if for water KB, or you can say this KB, this eboloscopy constant or boiling point molar elevation constant, this depends on nature of solvent. And this KB for water is universal solvent, and value of this will be 0.52 Kelvin kg per mole. And also we can write here 0.52 centigrade kg per mole. Both are same thing. You are not to add here 273 because it is also a difference delta T. Keep in mind. I think these things are clear to you. For better understanding, one numerical is required here. For numericals also one special video I will give you. Only one numerical we are to discuss here for clarity of the concept. And first you understand this. What is this? WB, mass of solute. We are taken in grams. MB, molar mass, gram per mole. WA, that is you are to take in gram. If kg is given, then you no need to multiply with 1000. And delta TB, you know, elevation in boiling point. And what is it? That is the difference TB minus T naught B. TB minus T. So take one numerical. I am happy. Numerical is like this: 18 gram of glucose. 18 gram of glucose is added into 1 kg of water. 1 kg of water in saucepan. In a saucepan. Find boiling point of solution. Find boiling point of solution. Given, आपको given है Kb for water, that is 0.52 Kelvin kg per mole. Boiling point of water also given, that is 373 Kelvin. ये आपका न्यूमेरिकल 2 or 3 times बोर्ड में आ चुका है, तो कीप इन माइंड. फर्स्ट इज discuss it. 18 gram of glucose. You know glucose here solute, and 1 kg water, this is solvent, and 18 gram, it means it is mass of solute is given, and mass of solute, mass के लिए क्या है WB, and B that is for solute, W is given, that is 18 gram. 18 gram. And 1 kg, this is the mass of solvent. WA, solvent के लिए A. And this is given 1 kg. 1 kg. Find boiling point of solution. Boiling point of solution means you have to calculate a TB. You have to calculate a TB. And this T naught B, that is given to you. This is 373 Kelvin. Also KB is also given. That is 0.5. Putting the formula delta TB. How you can write delta TB? That is TB minus T naught B. That is KB into my WB upon my MB, and this is WA, and here we are no requirement of multiply here 1000 because mass of solvent is given in 1 kg. So putting all the values, TB you have to calculate, T naught B, that is 373, KB, that is 0.52, WB, that is 18, upon my MB, molar mass of glucose, this also TB minus, this is 373, 18, MB, molar mass, that is generally given, and molar mass of glucose is 180, and WA, that is 1 kg. Like this you can calculate it. So this is all about elevation of boiling point. Thank you from my side. Have a good day.